Hello, good evening. Welcome to King David Electricals. This is David Electrician speaking. Today we want to discuss about forward and reverse control of a motor. So in this case, I have a MCB. I have contactor, two of them, for forward and for reverse. I have a start push button switch, a stop push button switch, and another start push button switch. I also have a motor, a fan here, which acts as a motor. We will use this one for this case. I also have a DC supply, which will drive the DC motor. So first of all, for us to achieve forward and reverse without any complication or without any errors, we must keep in mind that we want to connect this using the interlock system. By interlock, I mean at no given time should the two contactors go in at the same time. For us to achieve that, the supply of the coil for either motor should not go directly. It must pass via the auxiliary contact of the either contactor, the opposite contactor. So let us assume we want to drive the forward. We will not supply the forward directly. We must supply the forward through the auxiliary contacts of reverse. The same way, if you want to drive the reverse, we don't supply the reverse directly. We supply the coil of the reverse through the auxiliary contact of the forward. So let us explain. The power from the control fuse. Power is received at the control fuse. The output of the power from the control fuse goes direct to 9596 of the overload relay. 9596. So 9596 of overload relay is normally closed terminal of the overload relay. The overload relay helps us to achieve the motor protection against the overload or overcurrent. So if the motor is drawing a lot of current, the overload relay will trip, hence protecting the motor from burning or from dangerous damage. That is aside. Now the output from the overload relay will go directly to stop push button switch, which is also normally closed. In this case, we are going to bypass emergency stop because I don't have it here, but emergency comes first. Then output from emergency goes to stop, ordinary stop switch. Then output of stop switch goes to the first start switch. Then another one is linked to the second start switch. Since we want to drive the motors forward and reverse, we must have two different start switches because one will drive it forward, the other one will drive it reverse. Okay? Then after that, the output from the first start switch will go to the first contactor through normally closed of the second contactor. So let us assume this one is the second contactor and we want to supply this first contactor. We will connect it through the normally closed of the first contactor to normally open of the second contactor. Therefore, having a retainer. This one will act as a retainer so that when you stop pressing the start push button, the motor will continue running until you press the stop push button. At the same time, the output from the second push button will go to normally closed of the second contactor to supply the power to coil of the first contactor via normally close of the second contactor. and at the same time we'll have a connection through the normally open of the first contactor, which will act as a retainer. When you stop pressing the start push button, the motor will continue running. So at no given time will these contactors go in at the same time. So let us try demonstrating. So this is a DC supply, this is a DC fan motor. We want to try it if it can work. So this is the first start push button. So since this one is engaged, so this one cannot be engaged at any given time. Whether you press the second start push button, nothing happens. But if you press stop, it disengages. Then you press the second start push button, the motor is running. So in the first case it did not run because this contactor is faulty. The contacts are not going on. So at any given time, if you try pressing the first push button, it doesn't go on. So this one protects our system. I hope up to that point we are clear. We are trying to protect that motor from getting powers from different sources. The motor cannot go forward and reverse at the same time. It must just go simultaneously. You stop forward first, then you activate reverse, or you stop reverse, then you activate forward. So again, the first push button, let us assume this one is going forward, it will go forward. So at this time, even if you press this one, it doesn't engage. You stop, you press start, this one is engaged, but the motor is not running because the contact I've told you is not okay. So I'm sorry for that, but anyway, you can feel this one is engaged. So even if you press the second one, there's nothing which happens. You must stop it first, then you press this one. Stop, press the other. Stop, press the second one. Stop, press the first. Stop, stop, start. Stop, start. Thank you. I think that one is okay for today. If you have any question, feel free to ask in the comment section. I'll continue producing these electrical things. Thank you very much for your time.